Imagine draining every ocean, lake, river, and cloud on Earth, just to dump it all onto the sun. A desperate act or a mind-bending science experiment? What would actually happen if we poured the entire planet's water supply into our solar system's blazing heart? Would the sun be extinguished, or would we accidentally fuel a stellar inferno? Welcome to Deep Space Digest, where we unravel the cosmos one absurdly fascinating question at a time. The burning giant. Before we begin shipping blue oceans across millions of kilometers into the solar inferno, let's understand the beast we're dealing with. The sun isn't just a ball of fire in the sky. It's a nuclear furnace, a self-sustaining sphere of fusion so massive it accounts for 99.86% of the entire solar system's mass. At its core, it fuses hydrogen into helium, releasing colossal amounts of energy. Each second, the sun produces energy equivalent to 1 trillion 1-megaton hydrogen bombs going off simultaneously. At the surface, the temperature sizzles around 5,500 degrees Celsius, about 10,000 degrees Fahrenheit. But that's just the beginning. Deep within the core, temperatures reach a staggering 15 million degrees Celsius. Its diameter? About 1.39 million kilometers, large enough to fit 1.3 million Earths inside. It's not just hot, it's impossibly, overwhelmingly massive. And you think water is going to put this out? Earth's liquid offering. Let's talk about the water. Earth is known as the blue planet for a reason. About 71% of its surface is covered in water, but how much is that in total? Roughly 1.386 billion cubic kilometers of water exists on Earth. That's over 1.386 billion trillion liters. A number so vast it's hard to visualize. But let's try. Imagine wrapping the entire Earth in a 2.7-kilometer deep layer of water. That's how much we're talking about. So now we have our payload. Next question. How do we transport it? Delivery to the sun. The sun is about 150 million kilometers, 93 million miles away from Earth. Getting there isn't just a matter of strapping a tank to a rocket. Water is extremely heavy. 1 cubic meter weighs 1,000 kilograms. Multiply that by 1.386 billion cubic meters, and the logistics become insane. To deliver this mass, we'd need spacecraft thousands of times more powerful than anything ever built. Even if we melted the water into gas or ice to reduce volume, the sheer mass would be too much. But let's assume somehow we manage it. Advanced alien tech, wormholes, a cosmic-level water hose, doesn't matter, the water gets there. And now, we begin the pour. The splash heard across space. The moment Earth's water touches the sun, physics starts to scream. First off, the water wouldn't pour or gently splash, it would instantly vaporize. Within milliseconds, the sun's heat would convert the liquid into plasma and hydrogen gas. There's no putting out the sun. It's not a campfire. It's a self-sustaining thermonuclear reaction. Steam wouldn't even form. The water molecules would be ripped apart into hydrogen and oxygen atoms, then further torn into subatomic particles. The sheer heat ensures no recognizable molecule survives. In fact, ironically, adding hydrogen, which water contains, would actually fuel the sun more. You heard that right. Pouring water onto the sun doesn't extinguish it. It feeds it. Explosions and fusion frenzy. With a sudden infusion of hydrogen from Earth's water, the sun's fusion engine would briefly speed up. It's like pouring gasoline on a bonfire. This might lead to a temporary increase in brightness and heat, possibly even causing massive solar flares or coronal mass ejections. The sun would essentially burp, releasing torrents of radiation into the solar system. Planets could be bathed in intensified solar winds. Satellites and power grids on Earth, if any still existed, would fry. Mars might temporarily lose more of its atmosphere. Venus could get even more infernal. The whole solar balance would wobble. The Earth left behind. Back home? Things are worse than ever. We just gave up all our water. No more oceans, no more clouds, no more rain. Life? Extinct. Earth becomes a barren, rocky husk, eerily resembling Mars. The air grows dry and thin. Surface temperatures swing wildly without the climate-regulating properties of water. Plants die. Animals collapse. Civilization ends. The ocean's thermal buffer gone. Heat waves and freezes ravage the surface. And without oceans, plate tectonics would eventually slow down, increasing volcanic and seismic instability. Earth isn't just drying, it's dying. Did it change the sun? Surprisingly, not really. The sun is so massive that Earth's total water contribution would be like dropping a single ice cube into a raging volcano. Mathematically, it's less than a speck of dust in terms of mass. Even if the hydrogen boosted fusion for a moment, the effect would be minuscule. The sun's core wouldn't even register the impact. It would continue fusing hydrogen as always, unfazed by our desperate splash. The deeper consequences. This scenario reveals the scale at which our star operates and just how small Earth is in cosmic terms. Our total planetary water supply is nothing to the sun. It burns through 600 million tons of hydrogen every second. Even if all of Earth's water were composed purely of hydrogen, it would fuel the sun for only a fraction of a second. And yet, from our perspective, it's everything. It's the delicate balance of Earth's hydrosphere that makes life possible. Tampering with that, even hypothetically, highlights the fragile miracle we live within. What if we aimed for the core? Some might argue, what if we somehow directed the water not onto the surface, but straight into the sun's core? Well, even if we could tunnel through millions of kilometers of plasma, the sun's gravity would compress anything that enters. Any material, including water, would just become part of the fusion fuel. There is no extinguishing the sun from within. It's not a fire with a center you can stamp out. It's a nuclear reactor. Could anything put out the sun? Now that we've ruled out water, what could theoretically extinguish our star? Short answer, nothing we have. The only natural ways a star like the sun ends are burning through all its hydrogen over billions of years, expanding into a red giant, shedding its outer layers and collapsing into a white dwarf. It dies from exhaustion, not interference. Even black holes, the universe's ultimate destroyers, don't extinguish stars. They devour them. It's a different fate entirely. The real lesson. This wild scenario, while fictional, teaches us profound truths. The sun is not a fire you can douse. It's a fusion engine running on mass and time. Earth's precious water is irreplaceable. It's vital not just to us, but to the planet's geological and climate systems. Playing God with cosmic forces, like trying to pour oceans onto a star, reminds us how little power we actually wield in the universe. And perhaps most importantly, we don't need to change the sun. We need to protect the Earth. Epilogue: a scorched Earth. In the end, Earth would be left scorched, dry and silent. The sun would shine on, unaffected. And we'd have learned a terrible lesson, that sometimes the greatest threats come not from out there, but from our choices down here. So next time the planet feels too hot, maybe look to innovate, not obliterate. If you enjoyed this journey through the unimaginable and you love asking big what-if questions about the universe, don't forget to subscribe to my channel, Deep Space Digest, where we explore the cosmos one wild idea at a time.